Hello everyone. So right now I am with Dr. Chandrasekhar Yadav, who is a faculty in School of Physical Sciences in IIT Mandi. So I requested sir to show us their facility. This is a lab, low temperature condensed matter physics lab. So sir, please help us.
Yeah, so please welcome. Come in. Yeah, so please come in. So I'm taking you to our low temperature laboratory. So here is we call this a PPMS laboratory, Physical Property Measurement System Laboratory.
Okay.
So here we do material characterization and down to very low temperature.
Okay.
When I say very low temperature, it means the temperature here can go to 1.8 Kelvin.
Okay.
So in general language, our room temperature is 300 Kelvin. So we can go to minus 271 degrees centigrade.
Too much cold.
So this much cold temperature we can do, and we can look at various exotic property of the material.
Okay.
You might have heard of superconductivity.
Yes, we have.
So we study superconductivity in these materials. So I will take you to our experimental
Okay,
setup.
so let us move inside.
So this is our PPMS system bought from Quantum Design.
Okay.
So what I would like to highlight, this facility can go to temperature of the 2 Kelvin, and right now the temperature is 24 Kelvin. You see 24.00 Kelvin.
Okay.
And at the same, it can go to temperature of a 14 Tesla.
14 Tesla.
14 Tesla. It's a very high magnetic field.
Okay.
So if you need to compare it with the general purpose MRI machine that you see, there the maximum field is 3 Tesla or say close to 4 Tesla. So here is a 14 Tesla field inside this chamber.
Okay.
So we put our samples inside this, and then we measure the properties like electrical resistivity for their superconducting property, specific heat,
Okay.
Hall effect, and all these properties.
So what kind of material you put here to test?
So here our students, they are working mainly on the transition metal chalcogenized material, which are of very much current interest. So the superconducting materials, they are some material which are called topological insulator materials.
Okay.
That's sort of the material we study. In addition to these, we study magnetic properties as well. So here the specific heat measurement, we do it for some oxide material as well.
Okay.
Oxide magnetic compounds.
Okay.
So here the one unique things that we should tell you. So like this system was commercially procured. So we can do measurement here. This machine can take all the data, all this. In addition, our students, they worked and they developed one more experimental setup. So that setup is going down inside this chamber, and all this equipment is now controlled by our separate setup, separate electronics.
Okay.
So we are using
control the temperature.
So we are using temperature and the magnetic field of this machine, but the measurement that we have put up is our own.
Okay.
Other than what the company has provided.
Okay.
So then here this setup that we are doing CVEC measurement or non-CVEC measurement, and we can do it using our own electronics.
Okay. So do you use some machine learning algorithms also in this data?
No, so for this data we don't use machine learning. So here all the interfacing part is done in the LabVIEW language. So this program that you see written in the LabVIEW language.
Okay, LabVIEW.
So if you look at this, what this data is coming, if I go to its block diagram, this is how this language look like. So can you imagine that this is a programming language, LabVIEW? So program is written in this mode, and on the front panel, what you see is up this. Whatever the data is coming up is like that.
Okay.
So our students, they write the program by themselves, and then that's kind of the learning they get.
Great.
So we have very good accuracy of the measurement. Like here, if you see this machine, this is a nanovoltmeter.
So this LabVIEW is still important?
No, so LabVIEW is just for controlling these equipment.
No, those students who are nowadays doing some course.
Yes.
So is LabVIEW is important software?
Especially this language is very much used for controlling instruments, especially in the research purpose.
Okay.
Most of the programming and machine control is done using LabVIEW.
Okay.
LabVIEW. But on the background of the LabVIEW is a C language.
Okay.
Right. So which is so that our students do. So and in addition, our students make some other extra setups. Right, so this is a one homemade setup for measuring high temperature resistivity, and this is a setup for you see measuring dielectric constant. So,
Okay.
but we can take this system and put it in the PPMS or in some other setup for the measurement purpose. And you see, this is the kind of data that we get on that. This is one of my former students. She was working on this system. Right.
Great
So
work.
I will take you to the another lab.
Okay, come.
So here we do physical property measurement, but there is another setup that we have. This. Uh, so so here is the magnetic property measurement system.
Okay.
We can do magnetic characterizations down to 1.8 Kelvin, that is minus 271 degree centigrade.
Okay.
And here the field is 7 Tesla. And this is one of the most sensitive magnetometer in the world.
Magnetometer.
Magnetometers measure the magnetic property. I mean, so everywhere in the world who is doing the high precision magnetic measurement, they use this facility. So IIT Mandi has also has this facility.
Great. So you can see, students, all the latest requirements for research in physics. I found almost all important setups here, and that is very nice point thing from or we can say about IIT Mandi. So anything else which we can see here?
Yeah, so I think here there are the two labs, and then I will show you that we prepare our own material.
Okay.
Right, so you will see we have some very high temperature furnaces. So like if you are come this side, so these are the very high temperature furnaces. They can go to 1500 degrees centigrade. So like right now you see the temperature
This
is,
is a setup of furnace.
this is a furnace, and
Okay.
right now the temperature inside is 1066 degrees centigrade.
Oh.
So we have some material kept at this temperature. It will be in this temperature for
So
seven.
this is on right now. Is there anything?
This is on. This is, you see, this is hot.
So why are you testing something?
No, so not testing. We are preparing some material.
Okay.
So right, when we want to make a new compound,
Mhm.
which has people have not studied,
Mhm.
so we take all the chemicals, we mix them, and then we prepare using this.
So some work is going inside.
So some work is going on. Whatever will come out after 10 days, we will take out, we will test it. If it is in a clean form, then we will go for the measurement on other machines.
Okay.
If the material is not clean.